Okay, so sometimes things are a little messy. So here's an example where we'd like to use our equality property, but there's too many things going on. We don't have something as simple as log base 5 of something equals log base 5 of something. But if you look closely here, there is actually something we can do to make this look a lot better. I have log base 5 of x minus log base 5 of 3. So I can use my log properties, particularly this one, log of a quotient rule. It says log base b of x over y is equal to log base b of x minus log base b of y. Well, this right here is basically what I have here, except instead of a y, it's a 3. And so I should be able to rewrite this as something like this, log base b of x over y. So let's go ahead and do that. So using my quotient rule, this will be log base 5 of x over 3. Put it in parentheses so we remember that that whole thing is part of the log. And it's going to equal log base 5 of 6. Okay, now I have single logs on both sides, and I can use my equality property. If log base 5 of x over 3 is equal to log base 5 of 6, then x over 3 must be equal to 6. So let's write that down. X over 3 has to equal 6. Times both sides by 3 now. That'll get rid of the 3 over here. We have x equals 18. Okay. Here's another example. Now this one, I could not only use my quotient rule, I can also use my power rule. So remember, my power rule says if you have a number multiplied out in front, you can use it as a power on the inside of the log. So this 2 here can be a power here. Now, you do have to be careful. That 2 is going to be a power of both the 3 and the x. So this is going to become log base 5 of, I'll put some more parentheses here, 3x squared. Okay. And the reason why you got to do that is because that power is going to be everything in, they call this the argument of the log. It's going to be applied to everything in there. You could also think of this, so 2 times log base 5 of 3x is log base 5 of 3x plus log base 5 of 3x. Okay, you're adding it twice. That's what timesing by 2 does, right? You're adding it 2 times. Well, if I use my product rule, which says that log base 5 of 3x plus log base 5 of 3x is the same thing as log base 5 of 3x times 3x, you can see how that's the same thing as log base 5 of 3x squared, right? So lots of ways of going about this. Eventually, we're going to end up here no matter how we do it. So let me clean this up. So we're basically going to get this for this part right here. And I can distribute that to 3x times 3x is going to be 9x squared. So I got log base 5 of 9x squared. So we just took this 3x squared times 3x by itself twice. We get 9x squared. Okay. Now to deal with this part that's still here. This still has a log base 5 of x. We haven't done anything with that yet. And so at this point, I can use my quotient rule because I'm subtracting these two things. This will be equal to log base 5 of 9x squared over x. Okay, just using my quotient rule to say this thing and this thing, because I'm subtracting the logs, I can then just put them inside one log and divide them. Okay, and that is going to equal, so I haven't been keeping all the stuff coming down like I should, but this is going to equal log base 5 of 18. Okay, so that, all the way down to here still equals log base 5 of 18. Okay, and now I can use my equality property and say if log base 5 of 9x squared over x is equal to log base 5 of 18, then 9x squared over x has to equal 18. Okay, now before I go solving this, notice that we're dividing x squared by x. So again, this is x squared is x times x. Okay, and if I'm timesing by an x and then dividing by an x, they're basically going to cancel out and I'll have just one x left. Okay, so I did x times x, but then divided by x. So that's just going to be 1x. Still have the 9 because we didn't divide that by anything. So we got 9x equals 18. Okay, so I can divide both sides by 9. And you can probably see already that x is going to equal 2. Okay, so it's always a good idea to kind of double check these. Let's go up and just kind of show you what happens. So if x equals 2, let's put 2's in for the x's, okay? We're going to have 3 times 2, which is 6. So we'll have 2 times log base 5 of 6 minus log base 5 of 2. And that should equal log base 5 of 18. Now, you could type these in the calculator, type in log base 5 of 18, and then type in 2 times log base 5 of 6 minus log base 5 of 2, and you should get the same answer for both of those, okay? But also you could use your properties of logs to rewrite these. So this is going to be log base 5 of 6 squared. Let's get some room down here. Okay, so this is basically going to be log base 5 of 6 squared minus log base 5 of 2. Okay, well 6 squared is 36, so this is basically a 36 here. So now I could use my quotient rule and write that as log base 5 of 36 over 2. 36 over 2 is 18. And so this does in fact equal log base 5 of 18. Okay, so that's just kind of verifying that we had x right when we said that x equals 2. So x equals 2 is the answer. All this is just checking it to make sure that it makes sense that that's the answer, and it does.